Welcome to qnawire.
So now we'll work on problem 20 from chapter 17. In this problem, we're asked to say which of the following solutions is a buffer, and it gives us four situations with different mixtures. So the first one, the mixture is 100 milliliters of 0.1 molar acetic acid and 50 milliliters of 0.1 molar sodium hydroxide. Now, at first glance, it may seem like this would not be a buffer, simply because we have a strong acid with a strong base with a weak acid. However, we do have a buffer. We will have a buffer. And this is because the acetic acid is not consumed by the sodium hydroxide. The sodium hydroxide has fewer moles, and so it reacts with acetic acid to form the acetate ion. So we have a buffer between these two species. Now in the second part, part B, we're told about a solution made by mixing 100 milliliters of 0.1 m acetic acid and 500 milliliters of 0.1 m sodium hydroxide. Now here we have too much strong base, so the strong base completely consumes the weak acid. And we do not have a buffer. In part C, the solutions that we're told are mixed are a solution of 100 milliliters of 0.1 molar acetic acid and 50 milliliters of 0.1 molar HCl. Now here we have two acids. And since we have two acids, we cannot form buffer since there will be no reaction between the two. So in part D, we're given 100 milliliters of 0.1 molar potassium acetate and 50 milliliters of 0.1 molar potassium chloride. Now here we will not form a buffer because we have two conjugate bases, and the chlorine is not a good conjugate base for a buffer, but even so, it's a conjugate base and it will not form a buffer.